Let's try out tangent of cosine inverse of x. And so how can you do this? Well, I want you to take the inside function there and cosine inverse. So x is a length, and cosine inverse takes a length and turns it into an angle. So you call that angle theta. And then you get the equation that cosine theta equals x. So now your job is to draw a picture of this equation and then find out what's going to be tangent of theta using the picture. I'll pause for a couple seconds. I'll let you stop the video and go to work. Okay, now you've had a few minutes to work, or if you just want to see the answer and enjoy it, here we go. Let me explain my solution. So what I'm going to do with this, first, like I said, let's draw that picture. So I like to find a right triangle with angle theta. And I'm going to need cosine theta equals x. And so how can I do that? Well, cosine is going to be adjacent over hypotenuse. So what I might do is I might just label this side equal to x and hypotenuse equals to 1. So then calculating out cosine that's adjacent over hypotenuse, and that's just going to give me x over 1 equals x. And so now, like before, I want to fill in the other side, and then I want to use that information to find the tangent of cosine inverse of x, in other words, to find the tangent of angle theta. So how can I fill in this side? This is what? It's the opposite side. Using that Pythagorean theorem, I know that opposite side squared, side length squared, plus adjacent side length squared is equal to hypotenuse side length squared, and 1 squared is just equal to 1, of course. So I solve that equation. I get that the opposite squared is 1 minus x squared, so the opposite side length is nothing but the square root of 1 minus x squared. And so now that I've got that, I'm going to go ahead and replace this with what it's equal to. That's okay. And since I've done that, now I can erase my calculation. And now I want to find from this triangle what's going to be the tangent of theta. And so what's this one? There's different ways of thinking about this. You can think of tangent as sine over cosine, or equivalently you can say that tangent is going to be opposite side length over adjacent side length. So I'll abbreviate that by saying opposite over adjacent. And here I'm getting now the square root of 1 minus x squared all over x. And so you put that all together, you go back to the original problem, and you see that the tangent of cosine inverse of x is now equal to the square root of 1 minus x squared divided by x. And that's kind of interesting. When you break it up step by step, when you look at the component parts, none of the steps are that challenging. But when you look at the entire equation, that's really something, especially if you've never seen it before.